So as we know, IB should be equal to 2 times IA. So now I am substituting the values of IA equal to 1.2. 2 into 1.2 amperes will give 2.4 amperes. So IB is equal to 2.4 amperes. Similarly, the current flow in RC will be equal to IC. That will be 3.5 times IB. So now 3.5 into 2.4 will give us the value of the current. So it will be equal to 8.4 amperes. So now the value of IC is equal to 8.4 amperes. So now if you add 8.4 plus 2.4 plus 1.2, we will get 12 amperes. So this is the current in the each resistor or each load we have calculated. So next we are going to find out the value which is called the voltage. So the voltage value should be equal to, the power should be equal to V into I. So the power is, we know, 3 kilowatts and I will be 12 amperes. So the voltage should be equal to 3000 by 12 amperes will give 250 volts. So the voltage will be calculated as 250 volts. So next we are going to find out the individual resistance value. So individual resistance value RA, RB and RC should be calculated. So once you know the voltage and the current of each load, then it is easy to calculate the resistance value. So RA should be equal to V by IA. So V is 250, IA is 1.2 amperes. So it will be 208.33 ohms RA. Similarly, RB should be equal to V by IB. 250 divided by IB is how much? 2.4 amperes. So 250 divided by 2.4 will give us 104.16 ohms. So similarly, the value of RC, V by IC, 250 divided by IC is 8.4. So the value of 250 divided by 8.4 will give us 29.76 ohms. So the resistance, individual resistance RA, RB, RC as calculated like 208.33, 104.16, 29.76 ohms. So next will be the individual power. So for calculating the individual power, so the individual power means again V into I for each resistor. So the first resistor RA should be equal to, we can say V into IA. Then it will be how much? The voltage into IA. So 250 into 1.2 will be the power in first resistor. So that will be 300. Similarly, power in RB. So V into IB. So it will be 250 into IB is 2.4. So this value will be 600 watts. Similarly, PRC will be V into IC. 250 into 8.4 will give us 2100 watts. So these are the three power in individual resistor: 300 watts, 600 watts and 2100 watts. Once again, if you add all these three, again you will get 3000 watts. So in this way we can able to solve this problem. Next, by using the Kirchhoff's law, we are going to solve this given circuit. So here the circuit is given with the two batteries, 12 volt and 10 volt. The resistors are 12 ohm, 6 ohm and 10 ohms are connected. And here the Kirchhoff's law, what it says, it is the voltage drop equal to the voltage rise, or sum of the voltage drop and rise will be equal to 0. So once again, now we can name these loops A, B, C, D, E, F. So we can write A, B, C, D, E, F. In that it will be again given as, first we have to consider the loop A, B, First we can consider A, B, E, F, A. First loop A, B, E, F, A. So in that we have to assume our Kirchhoff's law and we can able to write the equation. First with the battery when it goes from minus to positive, we can write as it will be minus 12 volts plus 12 into I1, and the combination of the current here, the current is I1, and in this loop current is I2. So here it will be I1 minus I2. So it will be plus 10 into I1 minus I2 is equal to 0. This is our first equation. So now simplifying this, so 12 I1 plus 10 I1 minus 10 I2 is equal to 12. I am taking this minus 12 to other side. So now adding this 22 I1 minus 10 I2 is equal to 12. Name this as the equation number 2. So now again I am taking the other loop, second loop, B, C, D, E, B. B, C, D, E, B. So we again considering the equation, we are writing the value current flow 6 into I2. Here it will be positive to negative. So we will take plus 10 volts and plus the current flow here will be I2 minus I1. So 10 into I2 minus I1 is equal to 0. Now simplifying this equation, again 6 I2 plus 10 I2 minus 10 I1 is equal to minus 10 volts. So 16 I2 minus 10 I1 plus 16 I2 is equal to minus 10 volt. So say this equation as 4. This is third. So now writing the equation 2 and 4, so 22 I1 minus 10 I2 is equal to 12 minus 10 I1 plus 16 I2 is equal to minus 10. So now we have to simplify using the mathematical help. So we can we can remove one term and we can find out the other term. For example, I am going to remove say I1. So now for removing I1, I can multiply the equation 2 with 10 and equation 4 with 16. Then so 2 with 10 and 4 with 16. So first I am multiplying 2 with 10. So 220 I1 minus 100 I2 is equal to 120 by multiplying 10. So I am taking now the equation 4 and multiplying with 16. So minus 160 I1. So it has to be equation 4 with 22, we are getting 220 I1 minus 22 into 16, we will be getting 352 I2 is equal to minus 220. So now we can cancel 220 and this will become plus 352. So totally 252 I2 is equal to minus 100. 250 I2 is equal to minus 100. So I2 is equal to minus 100 by 252. So by solving this, we will get I2 should be equal to minus 0.396 amperes. So in this way, we have used a mathematical summation and we are eliminating I1 and we calculate I2, that should be equal to minus 0.396 amperes. Now substitute the value of I2 in the equation. We can make use of the equation number 2. So from 22 I1 minus 10 I2 is equal to 12. So 22 I1 minus 10 into minus 0.396 minus 0.396 equal to 12. So 22I1 minus into minus, it will become plus. So 0.396 will be equal to 3.96 equal to 12. So 22I1 should be equal to 12 minus 3.96. So it will be given as 8.04. So 22I1 should be equal to 8.04. So I1 should be equal to 8.04 divided by 22. So by solving this 8.04 by 22, it gives us 0.365 amperes. So the value of I1 is 0.365 amperes and the value of I2 is 0.396 amperes. So now we have to find out the voltage drop in each resistor. So in 12 ohm resistor, the voltage drop is 12 into I1. I1 is 0.365. 12 into 0.365 amperes will give us the value of, using the calculator, 4.38 volts. Similarly, the drop in 6 ohm resistor is 6 into minus 0.396. Minus 2.376 volts, and 10 ohm resistor is, the current is I1 minus I2, so it will be 0.365 minus of 0.396 into 10 ohms. So it will be 0.365 plus 0.396, 0.761 into 10, 7.61 volts. So this is the drop in these three resistors, 12 ohm, 6 ohm and 10 ohm resistor. So in this way we can call, so that is we can solve the problems in the electrical circuits using Ohm's law and Kirchhoff's law. I think you are all very much understand about this solving the problem. Thank you.